Welcome back. In this class we are going to discuss about the pull up to pull down ratio of an NMOS inverter driven by another NMOS inverter. You can also call this one as ZPU upon ZPD is equals to 4:1. That means you have to observe very clearly this is one NMOS inverter. Is it clear? Now you can observe this is one NMOS inverter, depletion mode transistor, and enhancement mode transistor, and one more inverter. You can clearly talk about this one, and one more inverter. Is it okay? Now this is VSS, this is VDD. Now this is a depletion mode transistor. This is enhancement mode transistor driven by another NMOS inverter. Now here you can observe very clearly that when Vin is equals to 0 here, what is the output here? 1. Is it clear? Which transistor is going to be turns on? Only the pull-up transistor is going to be turns on. Then the output is equals to 1. Then which transistor will turns on? Pull-down transistor is going to be turns on. Is it clear? That means you can observe very clearly that any one of the transistor is going to be turns on. In the first stage, pull-up is going to be turns on. In the second stage, pull-down is going to be turns on. Similarly, I will show in the form of symbols. Now you can observe that, don't forget here pull up is there and pull down is there. Here also pull up is there and pull down is there. Now you can observe if 0 is given, only pull up is turns on and the output is 1. Here the pull down is turns on. Is it clear? Now you can observe that if 1 is given, here, only pull down is turns on and the output is 0, and here only the pull up is turns on. If you observe that any one of the transistor is going to be turns on. Is it clear? Now I would like to tell the length by W is equals to the Z. Is it clear? Here if you talk about the length of pull up transistor upon the length of pull up transistor gives the pull up impedance. Is it understood, all of you? Now we will see some very quickly. Here you can observe this is an inverter, NMOS inverter driven by NMOS inverter. For equal noise margins we are going to operate in this region. What is this region, guys? V in is equals to V out is equals to V inverting. Can anybody try to tell? In the last class we have seen in the concept of CMOS inverter analysis and design. Absolutely. Is it clear? The V out and V in is equal, then we can call that one as what? Inverting voltage, which is equals to what? VDD by 2. Absolutely. Is it clear, all of you? Now you can observe that here. Very important point. Now you can observe very clearly this one. Why? Because if you talk about the very important point, when V in is equals to V out is equals to VDD, we can very clearly tell that the transistors are in operating in which region? Absolutely, in saturation region. We know that in saturation region, this is the expression IDS is equals to, this can be written as beta, right? But I am writing beta as K into W by L, as we have seen in the IDS versus VDS relationship. K into W by L, VGS minus VT whole square upon 2. Now if you observe that any one of the transistor is going to be operated, that means if it is a pull-up transistor, don't forget it is a depletion mode transistor. For depletion mode transistor, this VGS is equals to what? 0. Are you clear or not? And this can be written as what? K into W pull up by L pull up. I hope that are you clear? Similarly, if you observe that for enhancement mode transistor, this is the expression for enhancement mode transistor. Is it clear, all of you? This is the expression. What is the expression for an enhancement mode transistor? IDS is equals to K into W by L, where pull down transistor is the enhancement mode transistor, therefore PD upon PD. VGS. What is VGS now? Don't forget VGS is equals to V inverting voltage. I hope that are you clear for what is that? Enhancement mode transistor. Why? Because don't forget for enhancement mode transistor, the gate is connected to what? V in, and the source is connected to VSS. What is the difference between these two? Means V in minus 0. That means it is equals to V in. I can write this V in as what? V inverting voltage. Are you clear, all of you? Now you can further observe what is happening. Don't forget this is a current and this is also current, therefore I am going to equate the same currents. If you equate the same currents, you can observe very clearly here. If you equate the same currents, what will happen if you observe? Now see here, this is a saturation current and it is a saturation current. If you equal these two, then these two gets cancelled. I hope that are you clear. Is it understood? Yeah, absolutely. These two gets cancelled. Now you can observe very clearly this. In this way I have equated these two currents. Now if you observe that, we know that Z is equals to what? L by W. Here you are having W by L, therefore you can write oppositely. You can observe from here onwards, this can be written as 1 by Z PD, and also this can be written as what? 1 by Z PU. Is it clear, all of you? You can observe very clearly. Okay, then if you observe that 1 by ZPD into this term is equals to 1 by ZPU into this term. Is it understood? Now you can observe very clearly. This is the Z is equals to, then you can observe this one. Is it understood? Then after that, what should we have to do? Anybody from the class? Yeah, absolutely. What should we have to do? Yeah, we have to square root, we have to apply square root on both sides. After applying square root on both sides, you can observe very clearly, this square and this root gets cancelled, this square and root gets cancelled. Then what is happening? 1 by root ZPD will be the remaining term. And here what is that? V inverting minus Vt is the remaining term. Here what is the remaining term? 1 by root ZPU. Is it clear? Into minus VTD is the remaining term. I hope that are you clear. Now you can observe that after that what should we have to do? Yeah, absolutely. After that what should we have to do? Yeah, absolutely. We require V inverting, therefore you can observe that after splitting these two, or else you can take the ZPU by ZPD. What is happening after taking ZPU by ZPD? Observe that square root of ZPU by ZPD. Is it clear? Square root of ZPU by ZPD into this term. What is this term? V in minus V T is equals to minus VTD. I hope that are you clear. Now you can take this entire term to this side. That means we are going to calculate V in here. Okay, you can observe that very carefully. Here you can observe very carefully how this existing. Okay, now you can observe that, you can clearly observe, yeah, these two, absolutely. Yeah, I will show in this manner. Now you can able to observe very clearly. Okay, now you can see. Okay, see here, what is V inverting based on the above expression? Vt minus Vtd by Zpu upon Zpd. I hope that are you clear, all of you. That means you can clearly say that we acquired square root of ZPU by ZPD into this term. Is it clear? What is this term? V inverting minus Vt is equals to minus Vtd. Okay, now you observe that if this term came here, it becomes square root of ZPD by ZPU. Is it clear? After that, this minus Vt to send this side, then it becomes plus. This is the remaining term. I hope that are you clear. Now you should apply the typical values here. Now you can observe that the typical values of threshold voltage of depletion mode transistor and the threshold voltage of NMOS enhancement mode transistor and V inverting. Okay, after applying these values, this is the thing you are having. Is it clear? Now you can observe very clearly, this is the thing you are having. Yeah, absolutely. That means you can observe very clearly. I will show that after substituting the typical values, what is happening? Observe very carefully. Okay, first of all, you are going to send to this side, then 0.5 minus 0.2, it becomes what? Absolutely 0.3, it becomes 0.3. Is it clear? Now this may be 0.3. If you send this to this side, then it becomes 0.6. I hope that are you clear. Then it becomes what? 1 divided by 2 is equals to 1 by square root of ZPU upon ZPD. I hope that are you clear. Okay, after applying square on both sides, it becomes what? After applying square on both sides, the square root gets cancelled. It becomes what? 1 by 4 is equals to ZPU by ZPD. I hope that are you clear. That is the thing, 1 by 4 is equals to ZPU upon ZPD. Then finally you can tell that ZPU by ZPD is equals to 4:1. I hope that are you clear. ZPU by ZPD is equals to 4 upon 1. I hope that are you clear. That means if you observe that This is a thing you have to talk about. Is it clear, all of you? That is a very important thing you have to talk about. Then finally it is concluded that ZPU upon ZPD is equals to 4 by 1. What is the meaning of that? Can anybody try to tell? Just think for a while and imagine and try to tell what is the meaning of that. When an NMOS inverter driven by another NMOS inverter, okay, when an NMOS inverter is driven by another NMOS inverter, what is the meaning of that? Can anybody observe? ZPU by ZPD, ZPU by ZPD is equals to, okay, 4 is to 1. If you observe, okay, 4 is to 1. If you cross multiply that, what is that? ZPU is equals to 4 times ZPD. That means it is very clear that, okay, ZPU, you should maintain the length by width ratio of pull-up transistor when compared to pull-down transistor 4 times, okay, greater than the pull-down transistor. Is it clear? That means the L upon W ratio should be maintained for an depletion mode transistor, that is for pull-up transistor, okay, 4 times than the pull-down transistor. I hope that are you clear, all of you. Thank you very much. If you are having any doubts, you may ask. Is it clear, all of you?